Welcome back. We're going to do day 2 of 6.2, which is exponential models. And this time we're going to look at continuously compounded interest, meaning last section we looked at compounding interest, annually, semi-annually, quarterly, monthly. This time we're going to look at continuously compounding. What does that really mean? Okay, so first of all, the natural base E, it's a number E, kind of like pi and other numbers, is defined as the value of this expression. So this should look familiar, right? Like our growth rate, 1 plus 1 divided by x to the x time, as x approaches infinity. So like if we compound it infinity in like an infinite number of times. So the number E is an irrational number. So we're going to just kind of take a look at something really quick here. I'm going to bring this over here. So we have this little table here. So assume that we have an investment of $1 in an account. It pays 100% annual interest rate for 1 year. This is this equation right here. So 100% interest. We take 1 divided by n, and n times 1. Okay. So what happens if I compound it, once a year, twice a year, 3 times a year, and so forth? You watch this this step, kind of steps up how many times a year we compound, and look at what the value is of the y value, our amount we get back. As we approach, 1,000 times, 10,000 times, 80,000 times, 100,000 times, this number gets closer and closer to this number 2.718 and doesn't really go beyond that. Okay. And so it kind of just gradually approaches it, 2, 2.5, 2.5, 2.6, and they get to this number 2.718. Well, that's this value E. Okay. And so we use this value E. It's a special number, 2.7182818, and yada, yada, yada. Okay. And that's how we get the letter E. It's a special number E, kind of like pi or anything else, but it's 2.718. And so we come up with this formula that's called the PERT formula. It's a special formula for compounded interest, but this time it's compounded continuously, meaning it's continuously, infinitely compounding all the time. It's not just daily, not monthly, but all the time. We call this the PERT formula. Okay, so we still have our principal, but instead of that 1 plus my interest rate divided by the number of months, we just go E to the rate times time. So see this little PERT. Okay, principal times E to the rate times time. Okay, and so if you look here, as we get up to like 100,000, it's just going to keep getting a little bit tiny bit bigger, but it's going to still stay right there around 2.718. Okay, so that's the value of E. So let's look at how to kind of calculate these guys. So Regina invests $12,600 in an account that earns 3.2% annual interest, compounded continuously. So anytime you see this word continuously, compounded continuously, we're going to use our PERT formula. Okay, what is the value of the account after 12 years? So we're going to use this guy right here. Okay, so my amount in my account is going to be equal to my principal. We put in there 12,600, and we're going to time this, the number E, and into the rate, up here to the rate, so 0.032 times my time, 12. Okay, and again, I should see that written out in your homework before you calculate it. Okay, and so now we're going to put that in here. Let's calculate this guy. So we have 12,600 to the E. And so here's my button right here, that little blue E. So go second function to the E to the, and I'm going to put in parentheses, so it's up there, so 0.032 times my 12, and then I will close my parentheses, and I will get back 18,498.63. $18,498.63 is what I will have compounding continuously. Now you do that compounding semi-annually or annually, you're not going to get that much money back. Okay, and so this just reminds you to make sure you simplify properly the order of operations, because some calculators will not follow order of operations. Okay, so here you invest $125,000 in an account that earns 4.75% annual interest compounded continuously. What's my value after 15 years? So again, I'm going to plug this in here. I have A is going to be equal to, what's my principal is 125,000. That's what I put down, right? That's what I invest in, my initial investment. And then times E, and then my rate is going to be, we're going to move that decimal over, so 0.0475 times, and then my time is going to be after 15 years, and then we can calculate what our investment's going to be. Okay, so I'll put my calculator up here. I said put my calculator up here. There we go. So we have 125,000. Wish I had 125,000 to invest. Times E to the, now put this in parentheses, 0.0475 times 15. Boom. Wow, we got we doubled our money, right? 254,885. 254,885. And I'm not sure what the cents were on that. What do we got? 32 cents. 32 cents. Okay, so that's compounded continuously. Okay, so for this one, we're going to learn how to write an equation now. Okay, so Tia knew that the number of emails she was sent was growing exponentially. She generated a record of the number of emails she sent each year since 2009. What is the exponential model that describes the data? So first of all, write an exponential model in the form of y equals a times b to the x. Y equals the number of emails in hundreds, and x equals the number of years since 2009. So use the data to find the values of the constants a and b. So first of all, let's get our data. Okay, so 6, this is going to be 6. Right over here, we have 2016, she had 1,400 emails. That's 6 years, 2015, 2015, we have 1,000 emails. That's 6 years after 2009. So that's 1,000 emails. That's 6 years after 2009 because you calculate them since 2009, okay? Our second data point is in 2016, she had 1,400 emails. So that's going to be 7, which is 7 years after 2009. She had 1,400 emails. So those are our 2 data points, okay? So the growth factor of this is going to be basically our rate of change. So what do we multiply basically 1,000 by to get 1,400? We can find that out to get 14 divided by 10 because we're working in hundreds here, right? It says emails in hundreds. So we're just going to divide each of those by 100. So 14 divided by 10 is what gives me my 1.4. This is going to be my B. That's my growth factor, okay? So then we're going to write an exponential growth equation. Okay, we're going to go y equals a times b to the x, and we're going to substitute these guys, okay? We're going to use this y. We can use 14 right here, okay? We use this 14. So 14 equals a, we don't know what a is, we know what b is, times 1.4 to the x, which is going to be 7. Okay, so when this is 14, that's 7. So I should actually write this as 714 because we're going to use this in hundreds, okay? Okay, so right here now we're going to just divide by 1.4 to the 7th power. Divide by 1.4 to the 7th power. And let's see what we get here. We have 14 divided by 1.4 to the 7th power. And close my parentheses. Boom. About 1.33. Okay. So we know that our value of A is about 1.33. Now, once I know that value of A, I can come up here now and so y equals A 1.33 times my B. I know my B is 1.4 to the x. And there's my equation that represents that growth of my emails. Okay. All right, so let's take a look at another table here. So write an exponential function that includes these 2 points. So one thing I want to notice is whenever my values go from 2 to 3 consecutively, I can just kind of look and see my relationship between these 2 values. Notice that this doubles. If that's doubling, that means it's being multiplied by 2, which becomes my growth factor. Okay. I can also take just 4 divided by 2 and get the same thing as well. So I know that my B is going to be equal to 2. Okay. So same thing again, I'm going to take my y equals a times b to the x. And I can take, just one of these points here. We can take this one if you want to and go 4 equals a times b, which is going to be 2. Okay, to the x power, to the 3rd power. Okay, so divide by 2 to the 3rd, divide by 2 to the 3rd, which is basically 4 over 8 equals a, which is 1/2 equals a. Now I can rewrite y equals a 1/2 times my b, which is 2, to to the x power. Okay. All right. Write an exponential function that includes these 2 points. Now these two you have to be careful because we have this coordinate 1, 4 and 3, 16. But notice that this is not consecutive right here, 1 to 3. We're missing this 2 in here. So I don't just go straight from 4 to 16. I go 4 to something to 16. And so sometimes it helps to just figure that out. And I think it's going to be 8, right? So 4 times 2 is 8, and then times 2 is 16. So my factor is going to be 2. That's my growth factor. Okay, so my b is equal to 2 again. Okay, then I can take my y equals ab dx here. Okay, and I can take one of these coordinates. So I can just take 1, 4. So 4 equals a times b to the x power. That's 4 equals a times 2. And I'll just divide by 2. So 2 equals a. I can rewrite this again. Y equals a times b to the x. And there you go. Okay, and that's how you write a model equation for a model. All right, so this just kind of sums up everything we've been learning. A general exponential model, my compound interest model, and then compounded continuously model, which is my PERC model. Okay, so you guys have an assignment in Google Classroom. It's in Excel, and I will see you all in class. Thanks so much. Talk to you later. Bye-bye.